In our last lecture, we introduced the thermodynamic property called enthalpy, a quantity especially useful for processes occurring under constant pressure. We also discussed the application of the first law of thermodynamics to isobaric or isochoric heating or cooling, and to isothermal compressions or expansions of pure substances in a given phase. The equations derived for W, Q, delta U, and delta H assumed that there was no phase change or chemical reaction during the process. In the present chapter, we consider the specific case of phase changes such as melting, crystallization, vaporization, and so on. We will derive new equations for W, Q, delta U, and delta H for such processes using the first law of thermodynamics and the knowledge that phase changes can be made to occur under constant pressure and temperature conditions. Our ultimate goal, reached in Chapter 3, will be to discuss phase diagrams as shown for water on the right side of the slide. We will learn then to determine the stability conditions for the liquid, solid, and gas states, and understand when phase transformations occur, either spontaneously or reversibly. In this chapter, we will assume that we know the phase diagram for the substance of interest, so we know the pressure and temperature conditions under which a substance may be in the solid, liquid, or vapor states. We will only be interested in characterizing the energetics of these phase transitions. We will learn how to calculate the work, the heat, the energy, and the enthalpy changes associated with such processes. We will start our discussion of what is meant by the word standard state. We will then make sure we have all a good understanding of the concept of phase. Then I will take a few minutes to go over the definition of the various phase transitions or phase transformations, such as crystallization, fusion, and so on, which you will need to memorize. We will discuss the meaning of standard enthalpy of phase transition and discuss the information hidden behind the magnitude and the sign of these physical properties. We will learn how to differentiate normal and standard phase transition temperatures, and most importantly, we will learn how to calculate delta U, delta H, W, and Q for phase transitions.